Alright, so we are starting Unit 4 today, and Unit 4 has all to do with types of expressions that we call quadratics. We're splitting a couple of the sections up into two parts, so today we're doing 4.1a, and that's going to be solving quadratic equations by factoring, one of our favorite stuff. So the first thing we have to be able to know how to do is how to solve or find roots. Now roots is another term for when the whole thing is equal to 0. Okay, so what we do for step 1 is we make sure the equation is equal to 0 and that the highest exponent is positive. So that means that if x squared is our biggest term, that the exponent cannot be negative 2. We have to get the biggest one to be positive. So then we're going to be able to use one of our factoring methods, any of the 7 that we talked about in the previous unit. And then step 3, we want to set each of the factors equal to 0, and then we'll be able to solve. So let's look at example 1. Example 1, we have 16x squared minus 36 equals 0. So the whole thing is already equal to 0. Our highest exponent, x squared, is positive, so we're good there as well. So then we're going to just factor this thing. Now remember, when I'm factoring, the first thing I want to do is look for a GCF, and I do have one in here. It's 4. So let's factor out a GCF of 4, and that's going to leave me with 4x squared minus 9 equals 0. Now I still have a difference of 2 squares, so we bring that 4 down, and we have 2x squared, or 2x plus 3 times 2x minus 3 equals 0. So that was step 2. We factored all of the way. So the final step, step 3, is we set each factor equal to 0. And the way that I do this is each factor means every single individual term. So 4 is a factor, 2x plus 3 is a factor, and 2x minus 3 is a factor. So I draw a line in between each of the factors, and then I set each one of those equal to 0, because if one of them equals 0, since I'm multiplying, the whole answer would be 0. So for example, if I can get 2x plus 3 to figure out which x is going to let the whole thing equal 0, even if none of the others come out to 0, when I multiply 4 and 2x minus 3 by this term, which is going to be 0, the whole answer will come out to be 0. So we have 4 equals 0. We have 2x plus 3 equals 0. And 2x minus 3 equals 0. So typically, however many factors I have, that's how many answers I will get. However, when we have a GCF that's a factor, obviously 4 can never equal 0, so that's not going to be possible. So in this case, we'll actually only have 2 answers. So I'm going to subtract 3 from both sides. That gives me 2x equals negative 3. And then I divide both sides by 2. So one of my answers is x equals negative 3 over 2. So if I were to plug in negative 3 over 2 in for x, my whole equation would multiply out to give me 0. So I can do the exact same thing for this guy. So I add 3 to both sides, and I'm going to get 2x equals 3. So divide both sides by 2. And my other answer is x equals positive 3 over 2. So there is a way that I can rewrite this. Since I have negative 3 over 2 and positive 3 over 2, I can simplify that to x equals plus or minus 3 over 2. So I actually do have two answers here, positive 3 over 2 and negative 3 over 2. Example 2. I have 45p squared plus 10p equals 0. So I do have a GCF in here as well. It's 5p. So let's factor out a 5p. That leaves me with 9p plus 2 equals 0. Now when I'm looking at 9p plus 2, that doesn't look like it can factor anymore. So I'm actually done factoring. So I'm going to draw the line between the two, and I'm going to set each of the factors equal to 0. So we get 5p equals 0, and 9p plus 2 equals 0. So we're going to solve both of them. So I divide both sides by 5, and that gives me p equals 0. So one of my answers is p equals 0. And then on this side, I'm going to subtract 2 from both sides. So that's 9p equals negative 2. And then I divide both sides by 9, and I get p equals negative 2 over 9. So my second answer is negative 2 over 9. And what I'm doing here when I write my answers, it's just a list of answers. You can't plug both in for x at the same time. You can pick either one of these, and I'll get the answer of 0 when I plug it back in. So we just list all of the possible answers. We don't have to write it as an ordered pair because it's not an ordered pair. We only have one variable, and that's p. Example 3. M squared equals 8m. Now this one is not equal to 0, so we have to get the whole thing equal to 0. So how do I get the whole equation equal to 0? I can subtract 8m from both sides. Now m squared minus 8m, those are not like terms, so I can't combine them. So I have to just rewrite it as m squared minus 8m equals 0. Now I can factor that. This has a GCF of m, so that's m times m minus 8 equals 0. It looks like it's factored all of the way, so then I'm going to draw my line in between and set m equal to 0 and m minus 8 equal to 0. M equals to 0, we're already done there, and m minus 8 equals 0 is pretty simple. We just add 8 to both sides, and I get m equals 8. So my two answers here are m equals 0 and 8. So I could pick either one of these two answers, plug it in for m, and I should get a true statement. All right, example 4. Example 4 is x squared minus 3x equals 54. So on this one, I also am not equal to 0 yet. So I'm going to subtract 54 from both sides. That's going to give me x squared minus 3x minus 54 equals 0. And we can factor this using the diamond method. So let's think of two numbers that multiply to negative 54 and add up to negative 3. That's going to be negative 9 and positive 6. So this factors to x minus 9 times x plus 6 equals 0. So then we take each of our factors and set them both equal to 0 and solve. So I add 9 to both sides and I get x equals 9. I subtract 6 from both sides and I get x equals negative 6. So my two answers here are x equals 9 and negative 6. Example 5. we have 16x minus 64 equals x squared. Now, if I subtracted x squared from both sides, that's going to make my x squared negative. And I wanted my term to be positive, my first term to be positive. So what we actually have to do is subtract 16x from both sides and add 64 to both sides. So we're going to move the other stuff all over, because that's going to give me 0 equals x squared minus 16x plus 64. So now my x squared is still positive and I'm equal to 0. So this is also a diamond method problem. I want two numbers that multiply to positive 64 and add up to negative 16. And that's going to be negative 8 and negative 8. So this whole thing factors to x minus 8 times x minus 8. I set each of those equal to 0. And I'm noticing that I'm going to get x equals 8 for both of them. So because I got the same answer for each one, there's actually only one answer to this problem, and it's x equals 8. So we only have to write it one time. We don't have to write it multiple times. Okay, last example, example 6. It's going to be worded a little bit differently, but the idea is still the same. So our wording here is find the zeros of the function by rewriting the function in intercept form. So they give us a function this time. The whole thing is not equal to 0. So when it tells us to find the zeros, basically all we have to do is take 0 and plug it in for y. So we just set the whole equation equal to 0. So there's nothing different really happening here. It's just not already equal to 0. So what we can do is plug in 0 for y. So now I can factor this thing using the diamond method. So I'm looking for two numbers that multiply to negative 30 and add up to positive 7. And those are going to be positive 3 and negative 10. No, negative 3 and positive 10. There we go. So this whole thing factors out to x minus 3 times x plus 10. We set each one equal to 0. And then we solve each one of those. So that gives me x equals 3 and x equals negative 10. So my two answers are 3, negative 10. And that's using factoring to solve. So for your homework over the weekend is from the big textbook, page 256, numbers 31 through 37 all, so that's 5 problems, and 44 through 55 all, so that's 10 problems. So you have a total of 15 problems over the weekend, and you're just using factoring to solve for x.